Greetings all, welcome. My name is Dan Stoltz, and I'm here to talk about a new open source project I just released this week. It is called JitNeuro, or JITNEURO. It's on GitHub under my account, dstoltz, DSTOLTS. It is a memory management for Claude Code. It is so much more than that. Basically, I have given Claude Code a brain. This has been a project in the works since probably 2024, early 2024, when working with coding agents and their inability to effectively manage sessions and session memory. So this has been a project that I've been working on for a long time, and I finally, with the new changes, particularly with Claude, the latest Claude 4.6, we've really gotten to the point where it has become enterprise grade. So I've decided to go ahead and release what I've got. There's a lot more that I'll be releasing in the coming weeks, but I've got enough up to make it, a viable product as is. In a nutshell, it is a bunch of commands. I have 12 commands, 5 shortcuts, 4 hooks. Actually, I'm up to 5 now, I think. And I have install scripts on GitHub. JIT stands for just in time. And think of this as a framework to help you get the most out of Claude. So the problem that I wanted to face, as I mentioned, was just the context, running out of context, compact, and then Claude is off the rails, forgets all of its rules. And the solution was build out an entire neural network of brain connections, memory, learning, clearing, and managing context. But when doing it, I didn't want to do it for an individual session or an individual repo. I wanted to be able to do it cross-repo and make it enterprise scalable. So what I did was I have session management, cross-repo session management. I also have cross-repo intelligence. And I'm going to kind of go into the detail of how that works as we go through this short video. So the high-level architecture is I have long-term memory, and the memory.md file, which is a standard Claude methodology, is learn patterns and routing weights. So think of this as really nothing but pointers. It's pointers to where things are in memory, in context. I have this concept of bundles. This is domain knowledge. And these are loaded on demand. So the idea behind the load on demand is the monolithic Claude.md file that I know from YouTube galore everybody tends to use. And that is a very inefficient way to manage memory. Now, I'll also note that with the release of the 1 million tokens just this week from Anthropic, it may seem like less of an issue, but my experience working with large context is the more context you get, the more likely Claude is to, and other frameworks too, the more likely they are to forget. And then I have this concept of engrams. So engrams are per project deep context, and they're updated with a switch called learn. We'll talk more about learn in a minute. So your working memory, your context window, has very limited capacity. So in Claude MD, I have my core rules. These are always loaded, but it's very, very small. And I'm going to show you examples of what my Claude MD file looks like. And then we have active bundles. So the active bundles are task-relevant knowledge only, and these are loaded just in time. And then the short-term memory are the checkpoints or the session state. These survive clear. Key concept here, even after a clear, I still have the short-term memory. This was a key to really having full learning capability of the AI so that I can not only learn rules and guardrails, but enterprise concepts. There are some limitations with Claude, and I've submitted a feature request for some for enterprise features that I need Claude, that I need Anthropic to enable, to make it as tight as I'd like to make it. But even with the way the code is now, it is very, very, very good at managing with enterprise type rules. I do have a quick start to help you get started and get it installed. Basically, it's just a bunch of Bash and PowerShell scripts and MD files that install inside of your Claude or inside of your repo. And you can run it in a multi-repo environment like I'm running it now, where I have it in a code folder, and then inside that code folder I have different repos. Now, you could run it also in your user environment, which actually I have set up as well, so that if you're running it in the user environment, it can go cross-code all of your code. So like in my case, I have a code 1, 2, 3, 4, where I have different projects. So instead of installing it in all 4 locations, I install it at the user level, and it can, in the rules and the memory and the learning, the brain, if you will, can span all of my code bases. And whenever I say code 1 through 4, I really mean entire working environments. So, my code folder is going to have potentially 5, 10, even 20 repos in it. Some of those repos make up multiple products that work together. Some of those repos are a single product that, spans across multiple repos. But in any case, the brain, the intelligence, can go across all repos. You can also use JitNeuro with Cursor, but due to Cursor's lack of /command integration, it's not nearly as elegant. So you have to give it real commands. Tell it to use the rules. Tell it to use the commands. Without /commands, you just tell it, use JitNeuro save, so that it knows what it's saving, since the /commands are not available. So the file structure, I have commands, bundles, engrams, hooks. The hooks, I think, in the coming weeks, I'll have a lot more work in the hooks. That's probably the least mature part of what I've built and what I've released so far. And then the rules, and we're going to go through some of the rules, maybe even all of them. And then context manifest. JitNeuro JSON is for versioning, hooks, configuration, settings. And then again, this is showing the workspace root, which is how I think most people are probably going to be installing it. But again, you can install on the user folder as well. So the memory layer, and how the decision making works. First, it's a consolidated lifecycle with the /session, which by default is going to default to the current session. We also have the concept of the command of sessions, which refers to all. So you have different commands that you can run on a single session or on all sessions. You can name sessions and work on those sessions by name. You can do things like new session, load, pulse, switch, rename. So what is pulse? Pulse is, think of pulse as like a refresh. And I specifically didn't use refresh because I wanted to kind of stick with the neuro theme, but also, in anticipation that at some point, that might be a switch that Anthropic uses, and then I don't want to have to change it later. So pulse is something that I don't anticipate that would become a command in another system. So then we've got the memory layer. So you got session management, then you got the memory layer. In the memory layer, that's where your bundles, engrams, and routing weights lie. And within the memory layer, that breaks down into multiple components, and we'll get into that in a moment. So the memory layer has your orchestration for your session management, and the decision framework. So whenever in the code and in the documentation, I'll refer to kind of the stuff that we've talked about so far with the session management and the memory management. I'll refer to that really kind of as the brainstem. So that's the neural part of the network that makes all the connections happen, right? From firing off with the pulse to saving and loading memory and making sure things happen where they're supposed to happen. And then whenever we get into the brain, we really get into the decision models. So I've got decisions built into this and prediction rules. So one of the things that I wanted to get out of this neural network for Claude, if you will, is the ability for Claude to start thinking like I think. I don't want it to make decisions based on its model. I want it to make decisions based on how I would make those decisions. So this is also where guardrails go, but the decision model allows the brain the ability to learn constantly over time. So every time you use it and every time you use the learn command, and there are some components that learn automatically that you don't need the learn command. And eventually, we'll probably get to the point where everything just kind of self-learning. But the idea is, as I tell Claude something, I want it to always remember that context. And it's done in such a way that it doesn't use a lot of tokens. Like even when we were at 200,000 tokens for a session, my entire neuro brain and network was about 1%, or in some cases less than 1%. Of context window. That includes all guardrails. And the reason for that is complete optimization at every layer. And that is the loading what you need just in time. So the memory and the auto load of everything happens really from an index standpoint. And then as Claude needs context, it knows where to go to load that context. So the prediction rules allow Claude to anticipate what the user wants next. We have anti-patterns, which are learned constraints from corrections. So an example of a correction is, I've told you 3 times to go give me this answer. Now do it. So Claude automatically knows that I've told it that 3 times. That is an anti-pattern. That's me getting frustrated and saying, stop what you're freaking doing and go do it. So these anti-patterns are, think of these as intercept rules. Like, you've done this wrong, or you're being stupid, or key words that you might use whenever you're talking to Claude that these rules will go into an anti-pattern, which are, think of this as a level 0 rule. This is something that it is most important to the neural network. And we have this concept of persona weights. Which expert voice for which task type. And in an enterprise environment, whenever you're developing, you don't want to use just one persona. You want to use many personas. So whenever you're doing development, maybe you're a senior architect, maybe you're a DBA, maybe you're a front-end developer, maybe you're a UI UX tester, maybe you're an API tester, whatever the case may be. You're going to be monitoring maintenance, resilience. You have all these different personas that you work with. So we have different personas. In addition to all of those that I listed and more, we have the individual persona too of how my own persona. So we have persona weights for different for the way that we do things. So kind of complex, but you'll see when we get in the code, it's actually quite simple because of the way that we're doing this from a memory standpoint. And then we have our governance rules engine. So this is structured config for branching, trust zones, deployment gates, stuff like that. Because in an enterprise environment, you say don't want Claude to accidentally go out and push to main, right? You want to make sure that it's doing a PR. Now, I'm not suggesting that I'm going to allow, my AI to manage my security. I'm not suggesting that at all. I'm just saying this is you still want to set up your rules in your Git repo. But this gives you another layer of governance so that it doesn't hit those errors later. It kind of understands that context. And the reason it's important for it to understand that context is because it can take action in advance. So as an example, it doesn't have to try to go do the push to main. It knows in advance that I can't do a push to main. I need to do a PR, and it will recommend to me that it looks like we're probably ready to do a PR. So this intelligence of Claude coaching me through the intelligence that I give it over time. And the last thing that I'll mention before I get into the demo is I did release this MIT open license, so you're free to use it in any way that you see fit. All right, so we're jumped into demo mode. I have my Visual Studio Code open. And I'll just very quickly, the way that I typically run Claude Code is not using the button up here. I go into terminal, new terminal. I tell it what folder I want to work in. I'll just use the code folder. And then for the most part, I use dangerously skip permissions. In using JitNeuro, this is actually pretty safe to do because all of the things that we want it to do, we want it to do automatically, and it includes all guardrails, and the guardrails actually work surprisingly well. So I'm going to go ahead and run this, but I'm not going to. Actually, let me just show. List JIT JitNeuro commands with brief description. So the thing that I want to point out here is Claude Code understands the concept of what JitNeuro is. I also often refer to it as DOE. So kind of a shortcut for JitNeuro is going to be DOE because this becomes your DOE system. And you'll see that I have a bash error in one of my hooks. I'm not. I believe everything that's pushed is working, but you see here that whenever I'm talking to AI, whenever I'm doing things, I really let AI understand the context of everything that I'm working on. So I can onboard a repo, I can look up details on a specific bundle name, I have some enterprise capabilities built in, get status, can actually do cross-repo get comparison, local versus UAT versus main. That shows all dirty files ahead, behind. This is awesome. Particularly for somebody like me that works on a lot of different stuff, and I have ADHD, so I'm sometimes scatterbrained. I'll go pop into something and log some stuff that I want to do, and generally it's going to be discovery or some MD files that get updated, and then it just kind of sits there and never gets pushed. So get status is one of those tools for cross repo get comparison tool. And we'll talk about a lot of the main tools as we kind of go through the demo. So let me go ahead and get Claude Code out of the way for the moment, because I really want to go kind of through the system and talk about it. So we've got the JitNeuro repo, which has the Claude MD, and you'll see that the Claude MD incredibly small, right? The entire Claude MD for the project is 28 lines. So let's take a look at the Claude MD at a higher level. So that's at the individual repo. So let's look at the Claude MD here. And I am up to about 79 lines. Compared to, I used to have many hundreds of lines in the Claude MD. Now, a couple things have happened. Again, like I mentioned, the Claude MD, think of the Claude MD as your guardrails. And the guardrails and rules, other rules, are not necessarily going to be the key concept that we want to get to is we put the guardrails or the rules at the lowest possible level. So if it's a rule that covers multiple repos, then it needs to be at a higher level that covers multiple repos. But if it's, say, something on deployment, I don't necessarily want to have my deployment rules scattered throughout every single repo where there's a deployment folder. So I have overarching rules for deployment that will apply across repos, and then my individual rules for an individual repo, I can also add to that Claude MD in my deployment folder as an example. So there's this layered approach throughout. That's what gives it its just-in-time capabilities of I only need to read that context if it's relevant to the work that I'm working on right now. So as an example, my trust zones, I have green, which is read, search, analyze any repo, for research documentation, execute freely. Yellow, schema changes, like new dependencies, API contracts, env rights. So these things are only going to be allowed if they're specifically requested. And then the red zone is, even if I tell you to do it, you can't do it. Like, you got to stop, right? So the red zone is an example, push to main. Now, these zones can be overwritten. So as an example, I want to say in a particular repo, say the JitNeuro as an example, I do not want to push to main. I always want to do a PR, right? So I could have, at a higher level, I could set my push to main to be yellow, but then on that lower level, I can set it to red. Again, you're going to manage, permissions at the repo level, not necessarily in here, but it does give you some real advantages in there. So let's look at some of the things that are in my Claude MD file that is cross-repo. So I have the concept of JitNeuro. Actually, let me go back up a little bit because I touched on this a little bit earlier when we talked about DOE Framework. So your orchestration is really your DOE Framework. And this is so I am outlining here, the whole concept of the DOE Framework, and that this particular parent folder is a parent folder for all JIT solutions, AIBM, AI agency repositories, a bunch of other stuff. So this contains the DOE framework for that, and some quality standards that I've set in, right? Always use ASCII codes, don't put emojis and special characters that kind of mess up the display. Cross-repo protocols, right? That kind of goes in here. Again, this is your guardrails. So the JitNeuro write access, I automatically am giving access to write to these folders, even though they're not already in the repo. In this case, they are in the workspace. So the idea behind being able to give write access to that is as you learn, as the AI learns, we want it to automatically update these various different files. We want it to update the engrams, which is the project deep context. We want it to update the bundles, which is the domain knowledge, which is updated with the learn switch. We want it to update the session state. We even wanted to update various different manifests. So manifest could be in an MD, it could also be in a JSON. So an example of a manifest that gets updated is a keys, right? So you could store keys in a manifest file, which is a JSON. You could store keys in, say, Keeper and a Vault or Azure Key Vault or something like that. So you define these different manifests and how it works with your code base, and then it remembers that. So as an example, I don't have to tell it where to go to get the my Anthropic API key or my Gemini API key, or my YouTube keys, for creating videos, or my HeyGen or whatever. I don't need to tell it where any of that is. I also don't need to know I don't need to tell it how to connect, because that part of the system that it needs will have that information. So when it goes to look for, say, an Anthropic key, it's also going to have the context of what is the account for Anthropic. Whenever it needs to use something like HeyGen, it's going to already know what accounts are there. It's going to already know what my voice ID is. It's already going to know the variables that are associated with that context. And by doing that, again, it's just in time. It's not going to read that information. It's not going to go in and read the whole file, but it knows if it needs any of that kind of information, it knows where to go to find it. Then it can use grep, or it can search in those files and go grab the specific information it needs, so it doesn't have to read the entire file into context. So we have the concept of what are the slash commands. We have the concept of what are the shortcuts for the slash commands. So notice that most of the slash commands, I have the save, the load, the pulse, the status, and the dashboard. These are all shortcuts. Now that was done intentionally in case, I don't know, Anthropic wants to add a save or a load, right? So I bury that under the sessions, session save, session load, session pulse, session switch examples. And then I create shortcuts to those, so that down the road, if Anthropic does add those, it's very, very simple for me to go in, change a couple of lines, and boom, I can use save AI instead of save. And the entire system, doesn't have a lot of work. And then context loading. So this is the sequencer, the concept of reading the brain, the memory, and what it loads and when it loads it. And the concept of the project folders. If I'm talking about a particular project, I say, I want to work on JitURL. Like, I don't have to go switch directories or anything. I can just tell it I want to go work on JitURL. It's automatically going to know to switch to that directory, to change the context to that directory, to start a new session for that particular work, to create. If I tell it the context of what I want to do, it will go ahead and create the branch that I'm going to work on, because the rules say that I need to create a branch in this particular format. So all of that context, all of that knowledge of the way that I work is all built into the framework. And let's look at some of the other examples. So a scoped rule example, this is in the repo. You can take a look at that. Let's look at a JIT. Let's look at the JIT Neuro context. So this is the context file, the Engram, or the deep knowledge about this particular product. So it's a JIT memory management framework for Claude Code, persistent context across sessions. The technology used: Markdown, Bash, PowerShell, slash commands, hooks for Claude CLI. What version I'm on, what branch that I'm using, and where it's located on the machine, and where it's located in GitHub. Architecture that I'm using, key files that make up this system, and conventions, right? Commands are markdown files, not scripts. Engrams, 50 to 150 lines. Yes, that's very small. Facts only, updated by learn. So as I make changes to the system, I simply tell Claude to learn, and it will go and update this context automatically with the lessons that it learned. And it has the intelligence to know what it learned based on what I executed in that session. Some gotchas, and then the history of what happened. So the most recent change that I made was phase 2 cognitive layer started on 6/12, which was just a few days ago. I added 16 personas, activated triggers, biases, checklists, and stacking rules. And we're going to take a look at some of those personas. We're going to dig right into that to show you the most recent changes that I've made. And whenever I say the most recent changes that I've made, what I really mean is most recent changes that I've pushed, because a lot of the technology that I'm using, I've been using for a long time, and it's just, as I get to the point where I can release those features, I put it into the JitNeuro product. So let's take a look at learn first. So what is learn? So again, this is the learn command, and you'll see that it is a fair amount of context, 185 lines. Generally, the commands are going to be under 180 lines. The memory has a hard limit of 200 lines. And Engrams have a soft limit of 150 lines. So soft limit means this is what I want to try to stay to, but the reality is I could have 2,000 lines if I want. There is no hard limit, but so if you have a really big project, you would certainly want to have more. But what I try to do is I break those those engrams down to bite size. So in the case of my tech stack, instead of having one giant tech stack that's 580 lines, I have broken that tech stack into core and other components within the tech stack so that I have an index to those. So within learn, I have this concept of health, and I'm evaluating the health of that based on the number of lines that it of the memory. So I know, as an example, if my memory grows to 230 lines, well, Claude's only going to read the first 200. So everything over 200 is not going to be read. So I have to have a health to make sure that every time I'm doing a learn, or a save, I'm constantly monitoring the health of the system. So the system can self-diagnose and self-heal as we're going through the process. Um, um, we talked about the concept of payments, rollback flags, auth API, refresh. So there's some key things that are, these are proposed table changes. And I think I talked earlier, I certainly have it in my thought process of anytime that we're doing auth or when we're doing sync, that we want to have special rules. We want to have special processes. I already have those special processes that I follow, and those are recorded, like say, in those repos, in those places in code in the local Claude MD file. As I build out this system, I take those concept from those local MD files and I put it into the overall JIT brain, the JitNeuro brain. All right, let's dig into a couple of other things here. So more details on the health and specifically what's happening. It's checking the health of the memory, health of bundles, health of engrams, session state, weights. So it's not just memory, it's all of these things. And it's presenting in a table that looks something like this. Now, we also have this concept of information. So in information, and it's not here. I'm not sure where it is off the top of my head, but we show all the files that make up that session. It's probably in the session file, and the session file is probably the biggest of all of the all of the commands, session and sessions. So you'll see that this is kind of a long set of rules here. And we're even with as long as it is, it's only 280 lines. Everything is crystal compact in terms of optimization. And in fact, the more complex you make the rules, the more likely is that you're going to have issues with Claude actually following them. And then the sessions is basically using session, but it's the multi-session outline or the multi-session layer of handling sessions. So let's take a look at the orchestrator, and the orchestrator gives me the capability through this concept of manifest and memory of this cross-clear concept. So with my orchestration, I can, I don't need to run a manual clear or reload, or if I do want to run a clear to clear out my memory and start over, I have that orchestration layer to be able to do that. I have the concept of decision strategy. So as an example, I might have a single agent, things that I want to operate on really fast. I might have parallel agents which touch multiple independent domains. I have sequential agents where things have to happen in a particular sequence. And then I have the main context. Because within the brain orchestration, we want to be able to leverage the capability of using multiple sessions and multiple agents all the time. And as an example, whenever we're using multiple personas, we want to run those as parallel agents. So we have this concept of parallel agents that run simultaneously and leverage the capabilities of Claude Code. Oh, by the way, side note, Claude Code is very, very, very CPU heavy with a lot of the things that it does. On my development machine, I have, I think, 16 cores and 256 gig of memory, and whenever I'm running full sessions, I am using every single one of those cores. It is working, it's working hard, and it is working fast. Okay, so let's get into some of the other technologies. Let's talk about personas. Notice persona is really, really, really big. So probably the biggest file I have that makes up the section. And this is all about personas and how I define those personas and how those personas are used. So let's start with the beginning. So we have this concept of a primary persona, a secondary persona, and a silent persona. So um, a primary persona, this is a request that's directly in my domain. I drive the approach. A secondary, this is a request that touches my domain. I flag issues, check constraints, but don't drive it. And then silent is more of I'm monitoring, I'm watching, right? But I'm not actually touching any code. So within these different layers of personas on which persona is running, then we have the actual persona of how I'm acting. So one of the concepts that we do is we always announce the persona that we're using. So every time we run a task, we're announcing what persona is used for that particular task. And that's really for my own notification of how I'm acting, so that if I see any flaws in the logic of what Claude picks up as the needed persona for this particular task, I can say, "Hey, Claude, you shouldn't be using backend engineer plus security engineer. You should be using, systems architect as an example." Um, so, I can make those corrections on the fly. So whenever I'm defining these different personas, I also define what that persona is capable of doing or what their role is within the project. Again, all of these are customizable. It's just Markdown. And oh, by the way, this will change regularly and all the time, and it will change with part of the learn switch. All of this changes with learn. So as let's say that I have something that's running and it's running a senior software architect persona. And then I discover that as part of this senior software architect persona, I also needed to always check this or always act on that, right? So that becomes a lesson that updates the persona real time. So the brain is getting smarter with every interaction and every iteration. So I have the backend engineer and how it thinks, right? So every persona has a way to think. It has a bias, and it has what it auto loads. So in the case of the backend engineer, I always wanted to know what my tech stack is, right? So I'm going to load the core bundle, and I'm also going to load the integrations bundle. So this concept of just in time, here it is again, right? For this persona, I know I'm going to need those. I'm going to go ahead and load those. Those are in memory for that particular task. And this keeps Claude from making mistakes and doing things like, oh, I'm going to just stand up another auth because I don't know what my auth is. Um, we have a security engineer, we have a UI UX designer, we have DevOps engineer, and this is for your CI/CD, Docker, whatever. Maintenance engineer, right? Reliability engineer, SRE, content strategist. Think about any kind of persona that you would want to give your AI. Like, obviously we have the concept of a prompt engineer, right? So any way that you want Claude to act, you can define what it thinks about and its bias, and in what context it loads. So if I'm doing a content strategist, I automatically need to load my blog content bundle because that's where I put out my content first. The way I do my content is I put it out on my blog, I create a video, I put it out on social, but it all starts with a blog. So I needed to understand the context of the blog content bundle. And since all of my bundles are small, remember, most of them are less than 200 lines, I could run multiple auto loads for an individual task. And because those tasks run a lot of times independently, as soon as that task is over, I get the result, give it back to the brain by writing it out to the memory, then that task is done, that memory is freed up automatically. So you're real time managing the internal agents of what's running, and Claude does all the heavy lifting. And because of the framework, Claude knows how to manage this itself. So, decisions and decision making. root cause analysis is one of the things that I tell it I want to do. So this is how I define how it does root cause analysis. Now this is pretty basic, and I actually have a lot more context in my root cause analysis. This is basically if we've made a mistake, then I want to go back and do root cause analysis as to why we made this mistake, because I want to make sure we don't do it again. Now, this could be as simple as um, 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 you creating a new sync module when we already have a sync module. It could be that I used a tool that's not in the stack instead of a tool that is in the stack. It could be an actual thing that you learn from code. Oh, whenever I write this kind of code, X, Y, Z, say I'm writing an innate in workflow. Whenever I use innate in workflows, I always want to do X, Y, and Z. Right? Any kind of root cause analysis that you want to do, like say I'm struggling with my innate in workflow, right? I've been working on it for 3 hours. I can't figure it out. I've learned something from there, and I'll run my root cause analysis to understand how we got to where we got, where we're troubleshooting for 3 hours, and how to avoid getting through that so that I can update my context so I never hit that 3-hour roadblock again. Again, brain, memory, updating, real time, all the time, always learning. We talked about the concept of a pulse, and a pulse is nothing more than, there's this concept of constant learning, right? We're constantly writing out um, to these files, like my Claude MD, because that's my guardrail. But Claude MD is only read, as an example, my personal Claude MD is only read when I start a new session. So I have to have a way to say, go read everything that I've written to memory. And Pulse is your way to do that. So Pulse says, take what I know, or go look and see if the brain has been updated. And if it has, update my local session, my running copy of my brain, so that I can stay current. And then let's talk about learn just a little bit more. One of the key concepts that I want to talk about here is why I have a learn switch at all. Why not just automatically learn things? And the reason why is because often Claude will think it is learning something, but it has the wrong lesson. So as an example, it might learn that I always want to act like a senior software engineer in this particular case. But the reality is I don't want it to always act as a senior software engineer in this case. I want it to act like a senior software engineer with XYZ expertise, right? So I can tweak that message before it actually saves to learn. Because once it writes to learn, think of it as you're writing to your brain. You always want to have that human decision, that judgment on what goes into the brain, because that is how Claude is going to act. And you have empowered Claude to learn from you and act on your behalf as if you would have acted. So you want to make sure that you don't put any bogus rules in there. And that's why I almost always use learn rather than using the self-learn. So we talked, I think we talked about engrams. We talked about a lot of the commands. We've talked about root cause analysis. Let me talk about a few other things. So we have this concept of rules. Let's talk about some rules. So emergency procedures, engram toggles, all of my rules, notice they're all really, really small, right? Now, this is done on purpose. So there's this pattern of when asking owner a question, use ask user question. Now, there are cases, as an example, and one of the things that I need to teach on communication is there's an exception to this rule, and that is if the answer has more than, I think it's 5, say it has 6 potential answers, ask user question is not a good way to do it, because ask user question only supports 5 answers. So as we learn and as we grow, this communication.md rule pattern can be updated. But more importantly, we have the concept of overriding rules. I can say, as an example, that for this particular project, I don't want to use the standard communication rule. I want to use this instead, right? Or let's use persona as an example. I'm going to be doing a recording. I want to record an interaction with Claude that does not use my persona, right? Because I want to teach this particular lesson, right? So you have the ability within the system to turn on and turn off memories throughout the system. And those memories could be short term, they could be long term. So, this concept of being able to turn off rules, this is one of the key concepts of being able to turn off rules. Now, let's talk enterprise for a moment. So, the concept of rules should never be turned off if they're set at the enterprise level, right? Right. So we have an overarching rule that says if I set a rule at the enterprise level, it cannot be disabled. It cannot be turned off. You can make it, you can add to it, you can add additional rules to it, but any additional rule that's added cannot override my enterprise rules. So by doing that, I have the ability within the system to both lock it down and give flexibility. So let's talk about lockdown for a minute, because the reality is Claude doesn't have inherently the ability to, um, lock the system down. It has the ability to learn. It has the ability to write. So how do you lock down those rules so the developer can't just change them? Say, oh, I don't know. I don't like this rule. I'm just going to go back to my personal Claude and I'm going to tell it to not obey that rule, or tell it to allow me to override that rule. This is where we get into NTFS permissions, group policy, and stuff like that, where you as an organization can lay down policy to protect certain files. So we have a set of enterprise rules that cannot be overridden. Those rules are stored by group policy that the developer cannot change. And we have this enterprise ready solution that prevents developers from overriding it. Sure, they could not use the rules at all, go into a place that doesn't have rules defined at all. So, um, but the reality is, that's grounds for losing your job, right? And those kinds of things are probably going to be caught in the normal processes of PR reviews and stuff like that. So, Claude doesn't have the proper hooks to completely lock everything down. Again, I think I mentioned I did do some feature requests to give me more lockdown capabilities, and I hope Anthropic does that in the coming months. But as we get better and better and better at this enterprise stuff and learning, those features are going to come in really, really handy. But we already do have a lot of them, particularly whenever you get into the point where you're locking down different files. And so let me just give you some examples, and I don't know how many of these I've already pushed up into the repo, but I have the approval workflow. What's the process of going through an approval workflow, communication, cross projects, divergent thinking. Oh, this is awesome. Divergent thinking. So this specifically applies to enterprise quality. This does not apply to I need an answer fast. It is the opposite of I need an answer fast. So divergent thinking is this enterprise concept of I don't want you to just go find an answer. I want you to go find the best answer. So in divergent thinking, generally it's used in architecture decisions and new features and production code. When you're evaluating trade-offs, you're doing cross-repo changes, anything that ships to clients. When in doubt, use divergent thinking. And the whole idea between divergent thinking is you go generate 2 to 4 distinct approaches from different persona perspectives, not a plan A and a backup plan, genuinely different paths that each could be the best answer. You evaluate the pros and cons across all those paths: speed, safety, maintainability, existing patterns, including security, ROI, cost, whatever your rules are, and I've got all of those set up in the rules. Then I converge, I pick the best path. So this is your divergent thinking that humans are really, really, really good at, machines are really, really, really bad at. Now I have coded these really human traits into Claude Code to give it the ability to do these sorts of things. And then um, we can also add in here as an example, let's just, whenever doing divergent thinking, let's discuss the decisions and why those decisions were made. Now, this is a pretty advanced, and even this pretty advanced concept is only 17 lines long, right? Every single one of these rules are small, just in time. So it's not going to use, so actually the rules, all rules are pulled into memory at all times. So again, a reason why we want them to always be really small. Engram toggles, file references. How do I, what do I use the line number whenever you give me a, an absolute path, right? File versioning. I have a concept of file versioning. Every time if I'm doing strategy discussion with Claude, I don't want it to just constantly give me answers in chat. I have ADHD, so it's easier for me to read it in a markdown file. I can turn on preview and take advantage of tables and stuff like that. But more importantly, I want to revision that. Yes, I know I could, every 30 seconds I could do a commit and save that, but I don't want to do that. I want Claude to manage multiple versions. So if I'm talking about a strategy of, maybe adding a new feature to JitNeuro, like say as an example, expanding communication, then I can have that discussion in a strategy file. And then whenever I move, say, okay, well, let's go in a different direction. Let's add this, that, or the other thing. And then I can, Claude a lot of times will automatically recognize that there's a big enough of a change here that it's going to automatically version. If it's not, I can tell it, let's do another version and discuss X, right? So this file versioning concept is a rule that I've put into place on how to manage multiple versions of a discussion file. I also tell it that it's never going to version a Claude.md. This is only for, architecture files, or it's only for strategy files. It's only for MD files. So the exception is Claude MD. I also have this concept under file versioning of archiving. So after I version something, I also want to archive it. And then over time, we'll move to an archive folder. So how do we do archive? We give it a name, add a dot archive to it, and move it, and then eventually move it to an archive folder. Once we lock down on our final version, all of those other things can be can be done. Now, from a code standpoint, all those archives are my safety net of how I got to where I am. And I can leverage that knowledge for the entire session, even if it's across multiple sessions, multiple days, multiple weeks, multiple months. I can leverage that for decision making. And I do even have a decision making process. Looks like I have not added my decision making process into the rules yet. So it's actually quite extensive, my decision making process. So that'll be something I'm probably going to be adding in the next couple weeks. Memory architecture, it's a little bit long. It's 51 lines. And we talked a lot about memory already, so I'm not going to go into detail on that. Routing weights. So when we're loading bundles, we have this concept of routing weights. So whenever you hear these terms, or whenever we're talking about these terms, these are the things that we need to also understand. So this is, again, this goes back to your memory and your neural network, your brainstem, as I refer to it in the documentation. This is what maps to what, right? So when I do new feature planning, I want it maps to active work, my Ralph workflow, and my tech stack core at a minimum. That doesn't mean it's only going to link to those. That means that's the minimum that needs to load whenever I have that kind of a discussion. When I talk about the tech stack, I want to talk about the tech stack core and the tech stack apps, because when I'm talking about the tech stack, I'm probably going to be adding something. I want to make sure I have the full context of the tech stack. But I don't want to have to tell Claude, open all of this stuff. I want to instead tell Claude that let's work on the tech stack, and I want to let's look at what tools we can use. One example that I did just this morning, I was creating a blog post, and my N8N workflow for that blog post delivery, of doing additional research and stuff like that related to the blog post that I had just written. And I had Claude do some updates, and I looked at it and it looked like crap. So I said, we need to add a step before number 5, which is where I review it, that does that actually looks at the post before I do, to make sure that it looks okay, right? So adding that new rule in automatically triggered, oh, this is a tech stack, right? I need a tool to be able to do that. It automatically knew to go load the tech stack. It loaded the tech stack core. It loaded the tech stack apps to see what apps I could use to do that. It sees that I have Playwright already part of it, and it can go out and code that. So all of that neuro network is managed through the neuro weights. Guardrails and how guardrails work, sprint planning, trust zones, we talked about that already. Verify before claiming. This is something that AI does a terrible job at. It will claim something as a fact even though it is not a fact. So I have this verify things. You tell me something is missing or broken. Don't tell me it's missing or broken unless you have verified that it is in fact missing or broken. So as we add more and more and more rules, the system itself gets more and more intelligent. So this is a really long video already, so I'm going to end here and say there's a lot more this system will do. I hope you will consider being an active participant. I hope you will use it. I hope you will try it out. I hope you will provide feedback and suggestions on how we can improve it. And more importantly, if you're excited about making enterprise grade software, or if you're excited about making Claude Code even better than it already is, get involved. Help me build this out. Help me make it even better.